Okay, we proceed with the next question. The next question is a differentiation question from calculus. So before we was to solve this one, we have to find dy dx. So dy dx will be the same thing. We bring this one down. 10 times 2x to the power of 10 minus 1, and this will be minus 3 x to the power of minus 2, and then minus 1 times minus 2. So by implication, this will be the same thing as 20x to the power of 9 minus, this will be minus times minus will be plus, then this is 6x to the power of minus 3, yeah, to the power of minus 3. So we can write this one in a form of 20x to the power of 9 and then plus 6 all over x to the power of 3 as the answer. Yeah, so let's solve the next question here. The next question is to simplify fully, and to simplify fully here, we can follow it step by step in order to get it right. So you can check when you see this one, 5 is common. So we have 5 is common, and then we check here, xy is common, xy is common, then we are left with 3x minus, definitely that place is left with y in bracket all over the same thing. What is left here, it's we factorize 4. We have 4 in bracket. We have 3x minus y, close the bracket, then definitely this will kick out this one. When we kick out this one, our answer definitely will be 5xy all over 4. So the answer is 5xy all over 4 in this case. Yeah. So let's see the next question. In the next question, we have a kind of we have a rhombus here, and in this rhombus we say that ABC is a rhombus with side length 8 centimeter, and angle ABC is given to be 60 degrees. So we are asked to work out the area of the rhombus. And area of rhombus it's equals to a square sine theta. So in this case, this is gonna be definitely we have this to be 8 square, and then we multiply, we multiply by sine 60, and sine 60 degrees is equals to square root of 3 all over 2 in short form, and then this will be the same thing as we have 64 times square root of 3 all over 2 here, 1, 2 here will give us 32, and our final answer will be 32 square root of 3. Because we are asked to leave this answer in a root form, so this will be 3 to square root of 3 in centimeter square. So this is how we solve this particular question. Okay, we still have the next question 7. All right, that we have a question here. The curve y equals to this. Y is equal to this function, and then has a maximum point at L and a minimum point at M, and then they intersect the y-axis at N. So the curve crossing the axis at the 3 distinct points. On the axis below, sketch the curve. So for us to sketch the curve, what we will do first of all is to let x be equal to 0, so that we'll find the first coordinate. So that will be y in bracket 0 equal to, this is 2 bracket 0 to the power of 3 minus 3 bracket 0 to the power of 2 minus, just a moment, so this will be minus 12 in bracket 0, then plus 6. So by this we will have everything here. The value of y will be plus 6. So the coordinate of the curve will be 0, 6. So we have the maximum point. So we have this one. So we can we assume this, since it is not sketched on the graph sheet? So this minus 1, this minus 2, this minus 3, this minus 4, this is plus 1, plus 2, plus 3, plus 4, and plus 5. So this is minus 1. Sorry, I can't calibrate this because of the nature of this. We use 2, we use this one will be 3, sorry, 6, 4. This will give us 6, this is 10, this is 12, and then this one is 14, all minus. So this also it's 2, this also is 4, this is 5, 6, and this is 8, this is 10, on and on and on. So by implication, since that of y is higher, so what we'll do here in this place, it is supposed to be 2, 2, 2, 4, 6, and then this is supposed to be 8. That's the scale that we'll take here, the scale. Alright, this is 8 and this is 10. So to plot this, the first point L, when L is minus 1, yeah, x is minus 1, when x is minus 1, y is 13, plus 13. So plus 13 will be around this area, so they will meet here. Yeah, this is 13. We have the point here, that is L. Then the next one is we have x is plus 2, but y is minus 14. Minus 14 should be, okay, where zoom minus 14 should be here. So we have this is M, and then finally we have this, which is 0, and then we have 6. So 0 for y, for x, and 6 for this. So this will be, let me denote this to be point P. So this is point P. So we can sketch this one. Okay, we'll label it L, P, and M. Yeah. So the next question. Alright, we have a question here. A, B, C, and D are point on a cycle, and in this case we have B, C, A, and then A, C, D, C, A, D, and then C, A, B. So in this case, there are theorems that governs this. The sum of two opposite on angles of a cyclic quadrilateral is summed to 180 degrees. So in this case, this will be x plus 2 x, yeah, plus bracket 4x plus 3x in bracket equal to 180. So this will be 3x plus 7x equal to 180. So in this case here, we have this to be 10x equal to 180. We divide both sides by 10. So this will be 10, this will be 10, and in this cancel this, our x here is 18. So if we are asked to prove that AC is a diameter. So to prove that here is a diameter, we will substitute here. So when we substitute in this place here, what will happen is this value here, 2, for 2 here, it is 2 times 18, and 2 times 18 is 36 degrees. So the next one we substitute here, 3 times 18, 8 times this is 4, and then 8 times this is 3 plus 1, and then that's 44. So now we have 44 plus 36. 44 plus 36. When you sum this one, it will give us, this plus this is 0, carry 1. Then we sum this one, it gives us 80. So since we have this to be 80, now let's look at this. This is 80. This is 80. Sorry, let me check the other one. This one also 18. This one is 4. Yeah, 4 plus 4 times 18. So we have this to be 18. This is 4. 8 times 4 is 32. 2 carry 3. This time this is 72. Yeah, so this is 72. So we have this to be 72. The one of 3, can we sum this one? So when you check this, definitely here supposed to give us a 90 degrees. Okay, I think I need to work on this again. To show. All right, I'll work it out in the next question. So we have another one here, that f of x it's equal to this, and then g of x equals to this, where p is a constant. We are to, given that f of f is equal to this, we have to work out the value of p. So to work out the value of p, we substitute this into this. But before then, we can get the reciprocal of this. So f of 1 all over 3 into this, it will be 9 bracket 1 over 3 in bracket all over 2 to the power of all minus 1. So this will be equal to 3 here 1, 3 here 3. 3 times this, will have this to be 3 all over 2 bracket to the power of minus 1. So this, we can reciprocate it to be 2 all over, sorry, before then, let's leave it this way. So the next one is g of 1 all over 3 is equals to the square root of 1 minus p in bracket 1 all over 3, close the bracket. So this will give us the same thing as the square root of 1 minus p all over 3. So we can now equate this. F of 1 over 3 equals to g of 1 over 3. Then this will give us the same thing as 3 all over 2 in bracket to the power of minus 1 equals to the square root of 1 minus p over 3. So in this case, we square both sides. So we will square this both sides. We will have this to be 3. We reciprocate this. When we reciprocate this, we have 2 all over 3 equal to 1 all over the square root of 1 minus p over 3. So we can now square both sides. When we square both sides here, we will have this to be 4 all over 3 equals to the square of 1 is 1. When you square this one, it will go 1 minus p over 3. So this, I will take care of this first. So this will give us 1 all over 3 minus p over 3, which is the same thing as 3 all over 3 minus p. So by implication, and this one, this will be this time, this which will be 4 open bracket 3 minus p equals to 3 times 3 is 9. So this is 12 minus p equals to 9. So minus p equals to 9 minus 12. This will give us minus 3. And then our p will be equals to 3 because this will kick out this as our final answer. Isn't this fun? Actually, this is fun. All right, I will soon round up.